In the previous section, we saw how Lewis acids are electron deficient, while Lewis bases are electron rich. In a bond-forming reaction, we know by definition that the Lewis base provides or donates the electrons for the new bond, while the Lewis acid doesn't provide electrons, but accepts the pair of electrons to share. We made a list of what to look for, where Lewis acids were areas of positive charge and Lewis bases were areas of negative charge. Lone pairs or multiple bonds. This gives us tremendous predictive power as to where new bonds might form. But to start with, if we know the reactants and products in a bond-forming reaction, we should be able to work backwards and identify which reactant was the Lewis acid and which reactant was the Lewis base. In this reaction, molybdenum reacts with carbon monoxide to form a new molecule. Molybdenum is a neutral atom, so it's hard to determine if it will be an acid or a base. Same with carbon monoxide, although the carbon and oxygen should have partial charges. But if we know the reactants, let's work backwards from the product. First, we identify the new bond that forms. It's the molybdenum-carbon bond. Second, we ask who provided the electrons for the new bond. Where did they come from, molybdenum or carbon? Hopefully you can see that the lone pair that started on carbon ended up as the shared pair between carbon and molybdenum. Carbon maintains its octet through the reaction. Since carbon supplies the electrons for the new bond, we can identify carbon monoxide as the Lewis base and molybdenum as the Lewis acid in this reaction. In this reaction, fluoride ion reacts with water to form hydrogen fluoride and hydroxide ion. On the reactant side, fluoride is an anion, so we might suspect it will be the Lewis base. But again, let's ask what is the new bond that forms during the reaction. In this case, we identify the new bond as the HF bond. Then we ask, where did these electrons come from? Did they start on the fluorine or on the hydrogen? Hopefully we can see that one of the lone pairs on fluorine was converted into the shared pair in the new molecule. Fluorine started with 4 lone pairs and ended up with 3 lone pairs and a shared pair. You should note something else that changes. The shared pair in the original HO bond is converted to a lone pair on oxygen. While this won't affect our assignment of the Lewis acid and Lewis base, we will want to pay attention to that in future problems. Since fluoride ion provided the electrons for the new bond that forms, we can assign the fluoride as the Lewis base and water as the Lewis acid in this reaction.